Okay, yes. Okay, so in the last class, we were seeing about the knuckle joint. Okay, so just as one of them, some of them needed uh, just a small recap, I'll just let you know. See, there are many ways to draw this drawing. Okay, this knuckle joint. Okay, uh, so here they will only give only the diameter of the shaft. Okay, which will assume you here as 20 mm. Okay, and all this remaining dimensions, that is this 1.2 times d, zero point 0.7 times d, 3.7 times diameter, all these things we have to remember because these are all based on the design calculations, the standard proportions which has to be maintained. Right. Now, if you have to draw this, what you can do is that, see, I'll just overlap on this drawing and show you because it's easy for you to understand as in the recap. Okay. So what you can do is that, see, first what you can do is that this diameter is 20, right? So, but here for the you have totally some 4 or 5 parts. One is the rod, the pin, okay, and the collar, taper pin, fork, and the eye, okay, right? So this eye portion we'll draw first, okay. That is part number 2, which you can see here in the table, okay, right? So here what we'll do is, so eye portion is about 1.2 times the diameter. That means 1.2 into 20 mm over here. So we'll be drawing it for this particular length. Okay, for how much? That means for 1.2 means 24 mm diameter. Okay, length. Just look here how much they're given. They're given it as 4 times diameter. From where? Please look at it. From one end of the eye to the axis. That's all. To the axis. But where am I drawing? I'm drawing a little bit extra also. Why? Because the eye should also end. This particular rod should also end. So the ending portion is going to be here. So just look at this, where they have given. If you take a look at this 2 times diameter, so it starts from here, see this particular line, and ends here, where the eye rod should end. Okay, that this is 2 times diameter. So from the axis, it's going to be 1 time d, right? That is another 20 mm. That means this is going to be totally 5 times d. That means for 100 mm. So draw this rectangle for 24 by 100. Okay. Then what you do is that now you can draw the axis line. Now you can draw the axis line, draw this axis line exactly at the center, horizontal axis line. Then from the right hand end, take, say for example, how much it is. Now if you look at this, this axis has to be at a distance of 20 mm. This vertical axis has to be at a distance of 20 mm from the right hand side. Okay, and then this collar, sorry, not the collar, the pin diameter is equal to the diameter of the shaft itself. So that means it is going to be for 20 mm totally. So on 1/2 means it is going to be for 10 mm. So you draw 2 parallel lines from the right hand end. One from here 10 mm, then another 10 mm. So whatever you are drawn for 20 mm is going to be the axis line. Whatever you are drawn for 10 mm is going to be the one side of the pin. Okay, right? And then you can draw this for another 20 mm from here, so that you can get this one. You can just keep this as it is. Okay, if you know the length, you can draw it. So you can draw it exactly in your pencil and scale, but you will not get it exactly because we are drawing it from the center horizontal axis line. So just draw one parallel line. Just keep it as it is for the time being. Okay. Right. So as of now, what we'll be able to get is only so much, only this particular line. Right. Okay. Then what you do is, now you got this rectangle, right? This 24 by 100 mm whatever we have drawn. Okay. So from the axis line, okay, draw one parallel line, parallel from this vertical axis line, draw one parallel line for a diameter, for a distance of 20 mm. That means you'll get this length. You will be able to get this line. Okay. But for what height? See here, it should be for 0.7 times d. Okay, that means after this I, okay, from there above that 0.7 times d on both the sides, 0.7 times above, 0.7 times diameter below. Okay, so that means for 20 into 0.7, 14 mm, draw a line for 14 mm over here and draw a line over here at 14 mm. Then from here, what you're going to do is, what is this distance? For the, this is going to be the fork portion. So for the fork portion here, they have given it as 2 times diameter. That means 40 mm, right? So from there, what you do is, from here you draw one horizontal line for 40 mm. Okay, now I'll zoom in. Okay, you draw this line for 40 mm. Then draw this line vertically downwards for 2 mm. Okay, for 2 mm, you can see a small vertical line going downward for 2 mm. Then from there, draw one horizontal line for 4 mm. For 4 mm. Why you should draw for 4 mm, I'll tell you. See this distance? This is nothing but the end of the eye. But to draw this radius, he has drawn it at a distance, at some distance. Right? We'll see what is that distance now. Yes. Now look at this. What is, where is the center of this radius? It is at a distance of 1.2 times d. Okay, from the axis. From the axis. Okay, from the axis. Okay, so from the axis we have already drawn this end of the eye for 20 mm. Okay, but the center of this radius is at a distance of 24. So 20 plus 4, 24. That is why I am drawing this line for 4 mm. Right? Here also you have to draw this line for 4 mm straight line. Here also 4 mm straight line. Okay, right? And from the end of this eye onto the horizontal axis line, go for 4 mm, keep it as the center, draw the radius. Okay, draw the radius. Right? Now keeping the same center, okay, right? Draw this particular radius, which is going to be how much? He has given it here 1.2 times diameter. Okay, that means for 24 mm. Okay, so keeping this as the radius, this one as the for 24 mm as the radius, draw this. Draw this portion. Okay, from here look at this particular portion here. It has to be a radius of 0.7 times d, but in the opposite, where the center is not given. Okay, for this particular thing, for this particular arc, see, for this particular portion the radius is given, but where is the center? He has not mentioned. We have to find out the center. Okay, we have to find out the center. We cannot do approximate drawing over here. Okay, right? So for that, what you have to do is that to get this particular radius over here, okay, this particular radius 0.7 times d means it is going to be 15 mm. Okay, 15 mm. So what you do is, okay, so okay, let me complete it. Before going to this, what you do is, see this particular end onto the, now onto the right hand side where we have the fork. Okay, where we have the fork. Okay, this again, this particular distance is also, I mean, distance between these two parallel lines is also 1.2 times d. That means 24 mm. Okay, so what you can do is you can extend it. You can draw one light line as of now over here. Okay, you can just draw a light line as of now. over here. Now after this, what you do is, now take this line that you have drawn. From this, you go for 15 mm above. Okay, you draw one parallel line to this 15 mm above. Okay, you draw this line 15 mm above because this radius is 15 mm. Okay, then after that, what is this arc radius? It is 24. Okay, from there go for another 15 mm. So 24 plus 15. Okay, how much it is?
39.
Right, for 39 mm you take, for 39 mm you take as the radius, cut an arc onto this line. So this intersection point is the center to draw this particular radius. Okay, now keeping this intersection point as the center, take radius 15 mm, draw this arc. Okay, draw this arc, you will exactly get the tangent. You don't need to worry at all. You will exactly get the arc. Is that clear? Yes?
Yes, sir.
Okay, right. Now, after this, so what we have done the same, we have done this portion. Do the same procedure over here also, onto the other side also. Okay. Then next comes this particular line. Now look at this. How much have they given? From the axis, vertical axis, the fork is going to end at a distance of 5 times diameter. That means for 100 mm. So you just draw this, you have drawn this horizontal line, okay, parallel lines, which is at a distance of 24 mm. From the axis, vertical axis line, you measure 5 times diameter, that is 100 mm. Draw one vertical line. Okay, draw one vertical line. So this portion is not required. This portion is not required. Right? Now since you have drawn this arc, okay, right? Since you have drawn this arc, this portion is extra. You can trim it off or you can erase it in your sketchbook. So you'll neatly get this shape. Right? Okay. Then after this, what you have to do is, see, anyway, tell it here only. So here it is going to be this particular portion is going to be in octagonal shape, right? So for that, what you have to do is, here you take, this is for total distance is 24 mm divided by 1, 2, 3, 4. Okay, 2 divisions above axis line, 2 divisions below axis line. So 4 divisions, 24 divided by 4, 6 mm. Okay, each portion. So come down by 6 mm. From here you draw a line for 24 mm, or better thing is that you draw a line for 18 mm. You draw it at 18 mm. Okay, you draw it at, from here 6 mm, and then this horizontal line will be for 18 mm. Okay, now from here going exactly to this particular place, that is 18 mm from here, keeping this as center, just draw this arc. Okay, right? So it is going to be 18 mm, and from here it is going to be a radius. Okay, so this radius will be for a radius of 6 mm. Okay, right? So do the same procedure onto the other end also. Do the same procedure over here also. Okay, right. So now the next thing that we have to do is that, so we have drawn the eye, we have drawn the fork. Okay, now coming to the collar. Okay, now coming to the collar. Now collar, how much it is? It is 0.4 times diameter. He's given it here. 0.4 times diameter. That means how much? 8 mm. Okay, 8 mm. But look at this collar diameter. It's going to be a little bit smaller. How much is that? 1.7. Sorry, 1.5 times diameter. Okay, right? That means 1.5 times into 20. How much? 30 mm. No, correct. Right. So what you can do is that from the axis line, draw and go for a distance of how much? Uh, it's 30 mm. No? So go for a distance of 15 mm. So you will be here. From here, you draw for a height of 8 mm. Then go for this distance for 1.5 times diameter, that is 30 mm. Drop it down, and it is over. Now do the same procedure over here also. Okay, right? Now you come to this particular portion. The length of the uh, pin from its head is 3.7 times diameter. Okay, it is 3.7 times diameter. Okay, right? So you just see how much it is going to be. 3.7 times diameter means how much are you getting? 74 mm. Okay, right? So total length should be 74 mm from end to end. So you draw this uh, what pin, okay, whose total length should be 74, the including the head. Okay, if you're going to leave off the head, then you minus it by 8 mm. That means 74 minus 8. Okay, 66 mm is the length of this. From here, 66 mm. Close this for rectangle, right? And then coming to this particular portion, if you look at it, just erase these lines so that you can see clearly. Okay. Okay, now onto this collar, this particular rectangle that you can see here. Okay, what you do is that uh, this height is 8 mm. Okay, 8 mm. From the axis, you go to at a distance of 4 mm. Okay, keep a point for your reference. Draw one line. Draw one line. Okay, this line length should be how much? Let us see. Wait. Okay, what they have given. Okay, so this is what? 0.25 times the diameter at the bigger end. Okay, 1.8 times the diameter, it is longer. Okay, that is, this length should be 1.8 times long, okay, of the diameter. Okay, and then it should be tapering section where 1:50 ratio. That means after every 50 mm, the diameter is going to come down by 1 mm. Okay, it is going to come down by 1 mm is what they are given. Okay, now how to draw this, we will see. So 0.25 times is the diameter, right, at the bigger end. So you have drawn this axis line. Now from the center, what you do, the overall length should be 36. Okay, the overall length should be 36. That means from the axis you draw 18 mm on one side, then another 18 mm onto the other side, totally 36 mm. Okay, now 0.25 times the diameter, that is 5 mm. So from this end, from a left hand end of this horizontal line, okay, draw vertical line for totally 5 mm. That means 2.5 mm below, 2.5 mm above. Now come to this particular end. Okay, here what you do is you go in for, say for example, we have taken 2.5 mm, no? Since it is less than 50 mm, okay, what you can do is you go in for totally, um, totally 2 mm, sorry, totally 4 mm. So 2 mm below, 2 mm above. So totally 4 mm, this side it is 5 mm. Join this, you will get a taper pin, and it will be exactly at the center, right? Okay. And then finally is what? On both these sides, what you have to do is the diameter is of the shaft is 20 mm. From here, you just take some appropriate distance for the this uh, for some approximate distance of 15 or 20 mm you take. Okay, so that this should be for a distance of 20 mm. The diameter of the shaft should be 20 mm on both the sides. Draw a freehand curve like this and shade this portion. Right. Then what they have shown over here is the partly sectional front view. Okay. Not complete section. It's just a sectional front view. So what you do is you just go to freehand sketch, draw some curves over here in the eye portion, and here also in the fork end. Okay, and for the eye, look at it, look at this section. It is 45 degrees line which is moving towards the bottom right hand side. Okay, from left hand, top left hand, so top left corner to bottom right corner, that 45 degrees is going to be maintained. But for the fork end, it is going to be the opposite. Okay, the shading should be opposite because they are different elements, they are different components. Okay, right? So do it in the opposite 45 degree, that is from top right hand corner to bottom left hand corner. Draw horizontal, sorry, draw parallel lines which indicates the section. And next thing that you should notice is that look at the sectioning portion is shown only for the eye, fork portion, okay, and for the collar, but not for this pin. Okay, for that, generally for when you show assembly sectional views for nuts and bolts and such joining elements, sectioning will not be shown. There will not be any shading or hatching portions for that. Okay, right? Is that clear? Any doubts?
Clear, sir.
Right? Okay, there are
Yes.
many methods to draw this diagram. Okay, I feel this is the shortest method to complete it at the earliest. Okay, right. So this is only a sectional front view. That is what I did in the previous class, which is what is present here onto the right side, and that is onto the drawing sheets. Okay, now for this we have to draw the top view. Now to draw the top view is the same exact drawing. Okay, if you look at it, now just look at this particular portion, the isometric view of this. It is going to be uh, actually, what do I say? It should be actually, uh, anyway, it's going to be a rectangle, right? And here we have its octagonal shaped cutouts over here. Okay, and here we have circles, concentric circle, diameter 1.5 times diameter, 2 times diameter. And here it is going to be again a rectangle of width of 24 mm, right? That is what is going to be the top view with the taper pin that will be visible. So what you can do, you have to redraw this diagram once again, but not exactly the same. So what you can do is you can just project it from here. Okay, you can just project it from here. And this axis line. Okay, now what you can do is, if at all you want, you can draw this rectangle once again. Okay, rectangle how much? 24. Okay, and then the height is going to be, okay, width is going to be 24. So, okay, so here what you do is, okay, so 24 by 100, draw that same thing, draw the horizontal axis line. Okay, then from here also you can extend it, because we have again the same rectangle. Extend it. Keep it as it is. Okay, keep it as it is. Now from this intersection point, okay, draw one circle for diameter for this. Okay, that is the pin dia, which is equal to diameter of the shaft, which is 20 mm. Then again draw another concentric circle for a diameter of 1.5 times d, that is 30 mm diameter. Then another circle of 40 mm, that is for this fork end. Okay, that is, I am talking about this particular distance from here to here, 40 mm. Okay, right? So for this, draw from the center for a diameter of 40 for a radius of 20. So this, and yes, this, and yes, this, all the three will be continuous dark line only. Okay, and let me do this also. Now let me just show you this. So here you can draw the same pin. Okay, the same thing over here, reconstruct it once again over here. Okay, so in the same manner you can reconstruct it. Okay, and let me do that. And here the eye portion is for 24 mm, right? So we can see this circle completely, we can see this circle also completely. Here is the portion that comes into picture. Yes, I've drawn this. Second. All right. Right here at this particular end, we have to trim it off. Here it will be trimmed off. Okay, and reconstruct the taper pin. So what you can do is from here, I'll just draw one line for 36, no? So for 18 mm, 180 degrees, yes. Okay. So from here, what I'll do is this side it's totally 5 mm, that means 2.5 mm above at 90 degrees. And at the other end, okay, I'll extend this for another 18 mm on right side. Okay, and here it will be for a height of 2 mm, that is on one side. And I will join this. Okay, so this, and this will be a continuous line. We'll see that 1, 2, and 3. You can mirror this feature. Okay, since this pin will be going inside the collar, okay, we have to split it up at the particular portion. So it will get split it up over here. And here also. And this particular portion will be a hidden line because it will be inside. Okay, which will be inside. This is the only change in the top. Right. So here, as usual, you can take this. Okay. You can redraw this once again, this shaft over here, the small shaft portion. Okay, and similarly onto the other end also. Right. So this is going to be the top view for the knuckle joint. Okay. And of course, this portion should also be written once again. Same construction method. Okay, and this one also. Right? Okay. Yes. Any doubts? Hello.
No, no
Clear?
doubt. Yes, sir.
Right? So please be careful with the measurements, dimensioning. This is why we have to be very careful from where we should start the dimensioning, and from where we have to start measuring, from the axis line or at the end of the eye or whatever it is. So please be careful with that. Okay, right? And also the hatching also. Huh? For simple hatching is simple. For for the nut, the hatching direction is different. For the bolt, the hatching direction is different. So two parts, two different angles. That's all. Okay, I'm just gave a rough example, but generally for nut and bolt, we don't do any hatching. Okay. Right. Okay. So this is about knuckle joint. Okay. So next we'll go for the other drawing. Okay. Uh, right. Okay. Start drawing this. Okay. Uh, or shall we go to the next one?
Let's go, sir. We'll
Let's
draw
go.
it up.
Okay.
Done both.
All right. Okay. So just a moment. Okay, so the other type of joint that we have is called as the socket and spigot joint, or also called as spigot cotter joint. Okay, so yes. So how does this look? First, let us see that before going to the part. Okay, so we have totally three parts. One is the socket, spigot, and cotter. Okay, right? We have totally three parts. Okay, so just look here. So here, what you are able to see this particular circular portion. Okay, is the shaft diameter, and here also. Okay, and again to join these shafts, but these shafts should be in straight line. Okay, these shafts should be in straight line, in the same thing, not at different angles. Okay, so in that case they will use a spigot joint. Okay, and here we have a forged portion where you have again the socket. Okay, just like our what our plug points which we use for plugging and all those things are just similar to that. So this is the socket portion. Okay, and so this is going to have some particular diameter for a particular length, and from the other end of the shaft, again there's one extended portion uh, of the spigot. Okay, and both of them are going to go one inside the other, and one quarter, that means a tapering pin. Okay, a tapering pin is going to come into place. Okay, a tapering pin is going to come into place, which is going to hold both this shaft, that is the spigot and the socket. Okay, right. So all are in circular shape only, except this quarter. Okay, except this quarter. Right. Right. So let us see how to draw this. What are the design standards that has been given for this? Okay. Now here, if you look at it, so this particular portion is going to be the socket. This is going to be the spigot, and this is going to be the cotton. Okay. So now, if you look at it, we have everything once again in terms of proportions with respect to dimension. Sorry, diameter. Okay. So let's see how to draw this. Okay. So what I'll be first doing is that uh, I'll draw this particular rectangle first. I'll draw this particular rectangle even up to here. Okay. I'll draw this portion first. Okay, so what is the length? 3.3 times diameter plus 6 mm. Okay, that is the length of the rectangle. Okay, what is the height of this rectangle? 1.5 times the diameter. Okay, so diameter will take it as 20 mm. Okay, right. So let me draw that first. Second. All right, so let me draw that rectangular portion first. So I'll take it up from here. Okay, the height is going to be how much? Height is going to be 1.5 times, sorry, 1.75 times diameter. That means 35 mm. Okay, and length is going to be, the width is going to be 3.3 times diameter. 3.3 times into diameter. It's going to be 66 plus 6 mm they have given. So totally for 72. Yeah. Now I'll draw one horizontal axis line. Right? Okay. Now, next, what I will do is that I've drawn till here, this particular rectangular portion I've drawn. Now what I'll do, I'll draw this upper portion over here, okay, which is for a height of totally 2.5 times diameter. Okay, 2.5 times diameter means it is 50 mm. We have already drawn this for 35 mm minus 35, that means 15 mm. So from here it should go for a distance of 7.5 mm. So from here I'll take for a height of 7.5 mm, 90 degrees. Okay, and then what is this distance, this horizontal line? It is going to be equal to diameter, that means for 20 mm. And yes, so I'll finish it over here. I'll just drop it down. Okay, so now if even I'll just mirror it also. So now if I measure this, right? So how much it should be? 2.5 times diameter, that is 50 mm. So it is correct. Okay. Right. So let me darken this. You please better draw it first everything in light line. Finally, you can darken whichever the lines is required. I am drawing it dark because you cannot see it clearly. Okay, right. So this particular portion is also over. Right. So then what I'll be doing is that I'll be going in for this particular thing, which is 1.5 times diameter. Okay, that means how much it is? 0.75 times on one side into diameter, which is going to be for 15 mm. Right. So from here, what I'll do is that I'll go for height of 15 mm at 90 degrees. Okay. All right. Okay. At 90 degrees, this distance is going to be 0.4 times d, that is 8 mm, 0 degrees. So from here, 1.5 times d, so 30 mm, and close this. Okay. Right. So now we'll draw this inner portion, which is a rectangle for which is equivalent to the diameter itself. Okay. So this is going to be how much? Just a second, we'll see. Sorry, it is going to be 1.2 times diameter. That means 24 mm. Okay, 24 mm. Okay, 24 mm. And from what distance? It is going to be from here 0.5 times d. Okay, 0.5 times d. So what I'll do is I'll just draw an offset. Okay, 0.5 times d. How much it is? Half of diameter. That is for 10 mm, right? So just offset this line inside. Okay, draw it in light line, everything light line first. Then from there another 3 mm. So again offset. Okay, 3 mm distance from here for another 3 mm. Okay, right. Now what you do here is that now you can draw a offset line or you can come down below. Okay, while you're doing it on the system, while you are doing it onto your uh, on a on a sketch sheet, you can directly, once you get this point from here, you can go for a height of uh, from here you can go for a height of, it is 1.2 times d, that is half of that is 12 mm. Okay, 90 degrees, then you can go up to this end, right, and draw the same thing onto the other end also. Right, so I'll just trim this portion and show you so that you get some idea. So this is not required, this is not required. So we got this inside portion also. So here, what is this line? Again, parallel line. Okay, this is for a distance of 0.65 times d. So offset, I'll offset this time 0.65 times into diameter 13 mm. Okay, this particular line. $13 right, and then okay, and then from there another 3 mm. Okay, so offset this particular line by 3 mm here. Okay, right, so we got this inside portion also, let it be as it is. Okay, now the next thing is that we have to draw this particular quarter, which is a straight line from here. Total distance is 3.5 times d. Okay, 3.5 times into diameter, totally 70 mm. In that, half of that 35, because we are going to draw first on only on one side. Okay, so from here go for a height of 35 mm at 90 degrees, keep it as it is. Okay, and from here also go on to the other side for a distance of 35 mm minus 90 degrees. Okay, now here, now just look at this. Here they have told 1.3 times diameter at the center. Okay, at the center. Okay, right. So and here they're going, the taper is going to be 1:30. That means after every 30 mm, it is going to taper by a distance of uh, it is going to taper by a distance of 1 mm. Yeah, right. 1.3 times diameter. That is over here. He is talking 1.3 times diameter is over here. This distance. Okay. So 1.3 times to diameter, which is going to be 26 mm. Okay. So from here, it's going to be 26 mm. So what you can do is here at this top end, you can go for 1 mm extra. So 26 plus 1, 27 mm. Okay. At 180 degrees. Keep it as it is. At the other end of this quarter, 26 minus 1 mm you do it. So 25 mm. And join this. You will automatically get the taper. So one side it is going to be straight, the other side it is going to be tapered. Okay. And for this, you just draw one approximate freehand sketch like this. Okay. Right. So the next thing, what is left out? We have covered almost everything that is there inside. Now the next thing is only the shaft portion. Okay. So over here, what you can do is that from here diameter is 20, so 10 mm. So from there I just draw for some approximate distance. same thing onto this side also. Do the same thing over here also. So from here, diameter is 20, no? Okay. Mirror it. And using a freehand sketch, just draw approximately like this. Similarly, now, anyway, later on we can come to the hatching, right? Now look at this, in this particular portion where the quarter has been inserted, we have hidden lines. So let's split up in those particular regions. Okay, so go for split. So this is the reason why I told you draw everything first in light lines. Okay. Here. This has been split up. Okay, so this has to be split up. So we'll split this line here. And here. Okay, and similarly the same thing onto the other end. This will be split up over here. This will be split up over here. So this, correct? And this line, this portion here and here. All this will be hidden line. Okay, all this will be hidden line. Right? We darken these things also. And yes, we'll go for the shading. So before that, we'll just make one small okay. Here this end. Okay, this portion has to be trimmed off. Okay, and there is another 3 mm distance of clearance over here. So what you can do is you can draw a parallel line for this, parallel to this. Okay. right? So now what you can do is, before that you can go for a small fillet that they're given. They've not mentioned what is the radius. A small, it should not be sharp ends. Okay, so for that you can generally keep it at 1 mm radius. These portions. Yeah. Okay, and now you can go for hatching. Right. And right, we'll also have one free and sketch to show this particular portion and go for hatching in the opposite direction. Right. So if you draw like this, it's easy to finish the drawing completely, and you can show the dimensions. Just to solve the dimensions that has to be shown. It has to be 20 mm somewhere. Yeah. And then it's 24 mm. This overall length is going to be 70 mm. Right. From here to here, it is going to be 72 mm. Okay. And so on. Right. So this distance is going to be okay. And such dimensions you can show. Yes, so this is going to be the sectional front view for the Spigot joint. Yes, any doubts, or you want me to repeat anything?
No, sir. No doubts. All right. Yes. Sir, when will we be having the CAMD exam?
Uh, yes, CAMD first test. Yes, it will be held separately. So portions will be part A and part B. Okay, I will let you know about that. Probably first test of CAMD. No. Okay. So yeah, probably end of this month or on end of this month. Okay, both the classes. Okay, or else on November first week. Okay,
Oh, okay, okay.
right.
Okay, sir.
Probably
End of
I think better we can keep your test on Friday morning. That is on 23rd, because anyway
Yeah, but
part B.
23rd, I think some festival is there, sir. Or maybe 24th. I don't know.
Okay. All right. Otherwise on 19th.
Yeah, 19th will be good, sir.
19th,
19th we can.
because anyway part B also, part A we have completed, part B also I just now completed this socket and spigot joint. Okay, and part B, one more small portion is left out, we'll see that. Okay, so that is also there. Okay,
Okay.
right. uh, yes. Okay, so
Can you
now
upload
yes, tell me.
all of this to the Google Classroom?
Yeah, I'll upload it today, huh?
Okay,
Okay.
sir.
So for this, to draw the top view, if you look at this isometric view, everything is circular in portion. So when you look in top, it is going to look as front view as well as top view will look the same, right? So same drawings only you have to do it once again. Doing it on the system is easy, but doing it uh, onto your sketchbook is you have to draw the same diagrams once again. So I'll just copy this. Just a second. I'll just copy this. There are certain things that will not be there in the top view, but okay, there'll be certain changes. We'll see what are those changes. The first thing is that this hatchings will not be there because they have told only top view. That will be the first thing. Okay, and yes, we'll see this later on. So this thing, what is going to happen is that we need this line from here for a distance of 1 point, how much it is going to be, for 1.8 times d, 1.3 times diameter, that means 26 mm. Okay, so 26 mm, anyway, let it be there. So how to draw this top view, I'll tell you. We'll be able to see what in the top view, only this particular portion. Right, only this particular portion, which will look like this over here, as shown over here on right side, and they're given the dimensions for this, how to get this over here. Look at this particular thing. Okay, so overall distance is going to be 0.3 times diameter. Okay, and you have got a radius, curvature portion which has got a radius of 2 times diameter, but it is not going to touch the axis. Please see that there is a gap. See, there's a gap of 0.1 times diameter from the axis, horizontal axis line. Okay, now how to draw this, we'll see. Okay, so what's the overall length over here? It is going to be, I'll just remove this. This is at all not required. How much of this distance? This distance is 27 mm. So this is what we are going to draw here. Okay, I'll just move this. Okay, let it be 27 mm. Don't need this, and here also we don't need this. Also we don't need, and this line should be dark. We'll see that. Mm, it won't be dark. Let's see. Okay, fine. So from here, I'm just going to draw one line for anyway, let it be thin line here for 27 mm. Okay, and the width of it should be 0.3 times d. That means it should be only for 0.3 means how much? 6 mm? No, overall 6 mm. That means here it should be only on one side it should be 3 mm, and close this rectangle 27 mm, and here 6 mm at minus 90 degrees, and close this here again 27 mm at 0 degree, and close this. Okay, now what you're supposed to do, we have to draw that arc. Okay, so for that it's going to be how much? Just look at this. The center to draw this radius is the radius of this arc is 2 times diameter. That means 40 mm. Okay, 40 mm, correct. And it is going to be there at this, so plus this 0.1 times d. That means plus this 1 mm on each side. That means 40 plus 1. Okay, so we have to draw a line over here, or we have to go vertically from the center of this 27 mm, draw a line for a height of 2 times d, that is 40 mm plus that 1 mm, so 41 mm at 90 degrees. Okay, now keeping this as center, okay, radius should be 40 mm, 2 times diameter, that is what they have given. Draw it. Radius is going to be 40 mm. No, something is wrong, just a minute. No, it's not exactly at the center, that's the problem. I've drawn everything different places. This should be for a height of 3 mm, 90 degrees. Here 27 mm. Here 6 mm. Here 27 mm at 0 degrees. Close this. Okay. Now draw the, here you draw the line. Now from here you draw for this, you draw it at a height of 41 mm. From here you go to arc by center, radius 40 mm. Right? Okay. Now mirror this feature, do the same thing onto the other end also. Okay. Now what you have to do is that, you have to draw this arc over here in this particular direction, like this. I just show it in rough, just to come out like this. Okay, how to draw it correctly? I'll tell you. For this, okay, I'll just show you 1 second. Keeping this as center, this one as radius. Just cut an arc over here. So this is going to be center. So just look here. This is how you are going to do the construction to find the center to draw this particular arc over here. Okay. So what you do is, I'll show you once again. Take your compass, keep it here. Take this as the radius and cut an arc. This is going to be the center. Now keeping this as center, this intersection point, take this as the radius. Sorry, it has to come up correctly. Sorry, something is going wrong. Sorry. No, I don't think so. It is going to work. No, it doesn't work. We'll see. Wait, just give me some time. So anyway, on the system, you can do it by arc by 3 points. So 1, 2, and 3. Yeah, so how much are you going to get? So your radius is going to be 4.98 mm or approximately 5 mm radius. So what you can do is this length will be 5 mm. You go for a distance of 5 mm. From here you draw that, you will get it. Okay. There's no need to worry too much about that. And do the same thing over here. When you're doing it on your system, you can go by arc by 3 points. Now what I'll do is I'll trim the unwanted regions. All right. Okay. Right. And I don't need this line also. I'll put it as a very light line just for so that you can see. This is going to be dark. So there's nothing going to be here, and all these hidden lines will also be visible in this case because it is the top view, it is not a sectional view. And yes, this portion will not be visible. All lines will be visible over here. Even this cannot be seen because it is going to be inside. And this portion will also not be seen. It is going to be like this. Actually, sorry, these things will be hidden. This portion will be hidden. right. And here, in this portion here, it's going to be like this. Yes. Right? Yes, any doubts with this? Any doubts? So in the top view here, you can show the dimensions, especially for this, because the remaining dimension we have shown it in the front view. Okay, right. This particular dimension is what is required over here. Okay, or else what you can do some of the dimensions to be shifted into the top view. Yes, any doubts? Any doubts, or you want me to repeat anything? Yes, anything? Hello.
Yes, sir.
Yes, any doubts?
No, sir.
Okay. Right. Okay. Okay. Yes, all of you have you all downloaded the software that we had sent. We had sent the link.
Yes, sir.
So it should be for 2.4 GB. Okay, not 1 GB or 1.2 GB, because here you need even assembly drawing module also. Okay, so go to that new link and download it and install that particular portion. Okay, because shortly we'll be starting with the assembly drawing. Okay, we'll be starting with the assembly drawing, which is a major portion in CAMD. Okay, one question, 50 or 60 marks you're going to get. Okay, one assembly drawing will be there. Two assembly drawings will be given. One you have to choose and complete it. Okay, so you have a choice over there. But anyway, you have to be clear with all the assembly drawings, which takes too much of time and practice. Okay, right? So practice the drawings, complete the drawings, and upload it into the Google Classroom in the respective chapter headings. Okay, so I'll give it this as knuckle and quarter joint. You post your drawings over there. Okay, and similarly for threads, then nuts and bolts will be another chapter. All these things is there in the Google Classroom. Okay, so post your drawings, and that I think, are you people drawing it in a book or in a sheet of paper? Hmm? How are you drawing?
Sketches, sir.
Yeah, sketches.
For now, all in sheets, sir. Plain sheets.
Sir, sheets on the side.
All right, all right. So please keep all your sheets. Write your name, USA number, and all those on your sheets. Okay, and put the date also. Right. Okay. All right. So yes, Madhu P. Madhu.
Yes, sir.
Okay. Mane Paniraj. Not there. What happened to this guy? He's not coming early. Maushin. He's also not there. Then Naman.
Yes, sir.
Srikant.
Yes, sir, present, sir.
Pavan Kalyan. What happened to this guy, Pavan Kalyan?
Power left college, sir.
Huh?
Power left
He
college.
left college. He left the college, huh?
Yes, sir.
Okay, okay. Then Partha Sarthi.
Present, sir.
Rahul Rathod.
Present, sir.
Rajat Patel.
Sir, present, sir.
Okay. Then Reni Sibbi. He's also not there. Rohan Unikrishnan. There. Shreyas.
Present, sir.
What Shreyas? Today is your second class.
Yes, sir.
Where were you? Huh?
Sir, there's some network issue near my house, sir. I couldn't attend the class.
For how many ma? 1, 2, 3. 3 weeks.
Sir, I'll attend now onwards, sir.
Where are you? Which place?
Now I'm back, sir. I was in my native, sir, for the past
Where?
3 weeks. Kanakpura,
Where?
sir.
Where?
Kanakpura.
Hmm? Hmm. Right. Okay. Yes. Uh, Shashank Varnasi.
Sir, he left the college.
He also left the college. Yeah. Okay. Right. Samarth. Samarth.
Present, sir.
Okay. Sayam Govardhan.
Present, sir.
Sam Govardhan, you have to be regular. Only 3 classes you have attended. Why?
Yes, sir.
Where do you stay, man? Which place?
Here only, sir.
In Bangalore
Back.
only. Then why is
Yeah.
this problem? Huh?
Net issue, sir. Now I'll be there.
Then Sayatan is there.
Present, sir.
Okay, Shashank KS. Shashank KS.
Present, sir.
Okay, Shashank MV.
Present, sir. Present, sir.
Then Shivkumar Patel. Shivkumar Patel. Sri Harsha Prasad. Okay. Sri Harsha Prasad absent. Shubhankit Singh.
Present, sir.
Be regular from now onwards and cover up, learn all the drawings, whatever you have missed. Okay.
Yes, sir. Okay.
All right. Okay. So any doubts, or you want me to repeat anything? Right. Okay. So, all right. So we'll stop here for today. Complete the drawings, upload it to the Google Classroom in the respective chapters. Okay. Right.